Alright, looks like everything is working. Hello and welcome to a new video. In this video I'm going to introduce the part of my new series where I'm going to build my own programming language, like I already did that before, but I'm going to write the second version in Rust instead of C. So this is the repository of my first language. I will put you that in the description. And it's implemented in C. It's called Neo, like the guy from the Matrix movie. And let me show you quickly some of the code. For example, this is part of the virtual machine here. As you can see, it's all implemented in C99, which is really nice for portability reasons. And I thought I actually wanted to revisit the language and do a better design this time. And I thought, why actually not use Rust? C and C++ definitely have their place for a lot of software, even today, especially C++ for game development. But I thought, why not use Rust for the new language? It's also a pretty nice language, and yeah. So this is some of the code written in C. That's a compiler here, and yeah. So what I'm going to do in this video, I'm going to show you the design, like what the language should look like. And then in the next video, we're actually going to start coding it from scratch. Okay, so let me show you the design quickly. Okay, so the features of the programming language Neo. It should be simple. No feature bloat. I said it because a lot of modern languages like C++ or also Rust and also C#, they have feature bloat. Like they add a lot of features every release, and a lot of those features work or do some of the same things, and it makes it really hard for beginners to learn the language because it's so full of keywords and features. I want the language to be simple and easy to learn, like C. To program C correctly takes years, but to learn the language itself, like the keywords and the syntax, is actually pretty straightforward. There are some cursed things like macros or nested function pointers to arrays, but I think it's pretty acceptable. The next thing I want is a static type system. So Python, for example, is dynamically typed, but in my opinion, it increases or it allows more errors during development, because if I have a static compiler and I run my code, the compiler already checked if the static types match each other. But in Python, you can write weird code, and then this error will only be thrown when your code is actually executed. And a statically typed system compiler will basically check it when you compile your program, and it will already detect and find a lot of errors. And I want it because I really like static typing, like in Java or C# or also C++, when you enable the right compiler flags to be even stricter. So yeah, I want a static type system. Also remember that JavaScript was basically fixed up by TypeScript to also have static typing. Okay, so I also want the language to be interpreted, to run on a custom virtual machine. And I want it to be a scripting language. It's hard to say what a scripting language really is, but for me, a scripting language is when you can have a single file and just run it from your terminal without some kind of project structure. Like you have main.py, you can just run it. And for example, for some languages like Rust or C++, you need, for example, C++, you need a makefile or a CMake file. You cannot directly run the code. And yeah, I want it to be like a scripting language. I can create a single file and just run it. I also want simple data types, just like an int, a float, a bool, char, string, and a list. I don't want like those precision, like bit precision with integer types like you have in Rust or C, where you can say, okay, I want a signed 16-bit integer or an unsigned 32. I only want to have one integer. And I also do that for beginners because I want them to learn, like, hey, you want to represent a whole number, use an int. You want to represent a decimal number, use a float. You need a text, use a string. Like, I want to keep it simple. Okay, I also want first-class Unicode support. That's important today, I think, because I want to use the shit emoji as an identifier for a variable. Also, don't worry about my voice. I was ill a little bit this week, so sometimes it still sounds a little bit weird. And I want the language to be safe. For example, I wanted to report integer overflows, and I just want it to report errors that happen instead of swallowing them, and then make them later come up when you develop or enhance your program. Okay, so let's look at the data types. The integer is just a 64-bit 2's complement signed integer, like an int64t in C, or in Rust it's an I64. Remember that in C, signed integer overflow is actually undefined. In our language, it's going to be defined. So it's more like I64 in Rust. This is just like, yeah, the value must be within the whole numbers. And these should be the valid min-max ranges for 64-bit integers. But don't quote me on that because I know it's 2 raised to 64 minus 1 for an unsigned 64-bit integers. And we need to divide it by 2 because we give 1 bit to the sign bit. So we divide our max value by 2. But one of them is 1 larger and 1 is smaller. But I'm not sure. Like, I'm going to check that later. Okay, the float. It's an IEEE 754 binary 64 floating point for normal humans, also known as double or F64 Rust. Okay, the bool. The boolean is either 0 or 1, but we're going to implement it with an int under the hood and just waste 63 bytes because it's simpler to implement. Okay, a char. I just wanted to say a car, like what the fuck. A char is a 32-bit unsigned UTF-32 code point scalar. And why is that? Because same as in Rust, I want every emoji and weird symbol to fit into a single char. And UTF-32 actually can store in like any single character you can imagine in any language. And a string on the other side is UTF-8 encoded. You could, of course, make a string just a list of chars. But if you imagine that most of the English text is within ASCII range, which only needs 7 bits or 8 bits, like 1 byte if it's extended ASCII, you're wasting 3 bytes on every char, and I think that's too much. So I'm going to store them as UTF-8, and when you want a char out of them, you need to decode the UTF-8 into a character. Exactly the same as in Rust, and in C you could store them as a 1 byte unsigned pointer and allocate them on the heap or in a string pool, whatever you want to use. Okay, so what do we need to make this language alive and to build it and maybe even make people use it? So we need a compiler, of course, and for that we need a lexer, which basically turns your source code you wrote into a token stream or a list of tokens. And the tokens are just like identifying what kind of text you got. For example, return would be token keyword return, and like 3 would be token integer literal. I'm going to explain it in the next video. But yeah, it's just going to divide the text into tokens. Then the parser is going to get that list of tokens and convert it into an AST, which is an abstract syntax tree, which is like a tree representation of our syntax and of our code. And it's also going to check the grammar of the language, like if the grammar is correct. And the semantic analyzer will actually check if the semantic is correct. So for example, if you assign a string to an integer variable because the type system is static, the semantic analyzer will actually say, hey, you need to cast that or parse it or convert it to a string, but you cannot assign it directly. And then as the last stage, we need a bytecode generator, which turns it AST into bytecode, which can then be executed by our custom runtime. So for the runtime, which is like the Java virtual machine or the Python interpreter or .NET, the .NET CLR, for example. For that, we need a bytecode format, which can cross-platform and compress store our bytecode instructions for the virtual machine. We also need a fast virtual machine. Like, it doesn't need to be super fast, but we should be designing that it works fast, maybe with threaded interpreters or computed GoTo, if that's possible in Rust. I'm not sure. We need a garbage collector, either reference counting with some helper, a mark and sweep, or a generational GC even, I don't know yet, I need to decide. We also need an FFI, a way to call a foreign function interface, like a way to call native Rust or C functions. That's hard to implement because I think it's not possible to do that without generating machine code at the runtime. Maybe it is, I'm not sure, but this is really important because at one time we need to call C, like everything is written in C. we need to call C libraries, we want bindings to other libraries, and C is like the lingua franca, the common denominator there. So yeah, that's actually not that easy to implement because you need to generate machine language, you need to look for the calling conventions, and if you mess those up, it just might crash. But still, in the end, maybe a JIT, like a just-in-time compiler, which will translate our bytecode into machine language and only like the code which is executing a lot. That's also hard to implement, but would be fun to even build like a simple JIT. Okay, so for the first version, which we will start to build in the next video, I want to have integer data types, only integers. I want the following operations, like the basic arithmetic operations, like addition, subtraction, multiplication, division, modulus, and then comparison operators. Later we will of course add like bit operations and stuff like that, but for now those should be enough. Also I want function calls, I have a call stack. I want branching to have an if clause and an else clause to implement basic branching. And I want a while loop. And this one is important because with a while loop we can actually implement more complex loops like for loop, for example. And these are like the basic building blocks. If we have those, we can build upon these to implement more advanced features. Alright, so I will start programming the lexer of the compiler in the next video, and I hope to see you there, and I hope that you like this video. Leave me a comment what you think about the project, what you think about the design and the video in general, and I hope to see you soon. Bye bye then.